Dendro Zap here. Let's dive into one of water's most peculiar traits. What if ice didn't float? If water behaved like most other substances, lakes would freeze from the bottom up, completely changing our world. Instead, water reaches its maximum density at 4 degrees Celsius, not when frozen. This counterintuitive property is absolutely vital for aquatic life and ecosystems, a scientific quirk with profound consequences. Today, we unravel the molecular mystery behind this strange phenomenon. Most liquids contract and become denser as they cool, eventually solidifying into a more compact, heavier form. Water follows this general rule initially. As you cool liquid water from, say, 20 degrees Celsius, it steadily becomes denser. Molecules move less vigorously, packing more tightly. But then, something extraordinary happens when it hits approximately 4 degrees Celsius. The trend abruptly reverses, and as it cools further towards 0 degrees Celsius, water expands again, becoming less dense. The secret lies in water's unique molecular structure and the special bonds it forms. A water molecule, H2O, is bent, with oxygen attracting electrons more strongly than hydrogen. This creates a slight negative charge on the oxygen and slight positive charges on the hydrogens. These opposite charges allow individual water molecules to form weak electrostatic attractions called hydrogen bonds with neighboring molecules. Each water molecule can potentially form 4 such bonds, acting like tiny, flexible connectors. Above 4 degrees Celsius, water molecules possess enough kinetic energy to constantly break and reform these hydrogen bonds. This constant motion allows molecules to move around freely, ensuring efficient packing. As the temperature drops towards 4 degrees Celsius, molecules slow, and hydrogen bonds become more stable. At this crucial temperature, a perfect balance is struck, and molecules achieve their closest average proximity, resulting in the highest density. It's a temporary sweet spot before rigidity sets in. However, as water cools from 4 degrees Celsius to 0 degrees Celsius, hydrogen bonds' influence dramatically increases. Decreasing kinetic energy means these bonds persist longer, forcing water molecules into a more rigid, ordered arrangement. Specifically, they lock into an open hexagonal lattice structure, typical of ice. This ordered structure, while stable, actually takes up more space than the more haphazardly packed liquid state at 4 degrees Celsius. Molecules are held further apart by these strong, directional bonds. This open, less dense structure of ice is why it floats, a phenomenon critical for life on Earth. When a lake freezes, the ice forms a protective layer on the surface, insulating the denser, 4 degrees Celsius water below. This prevents the entire body of water from freezing solid, allowing aquatic organisms to survive the winter. Without this anomaly, many lakes and oceans would freeze solid from the bottom up, dramatically altering global ecosystems. It's a fundamental principle of our planet's biology. Stay curious. Dendro Zap, out.